So far we learned how to write toolpaths using parts with 90-degree corners. Even though they may have a radius on them, we have not had to figure out or calculate the angle on a feature of a part. So the first thing we're going to do on this particular part is take a look at the angled features and determine what information we have and don't have, and then the information that we need to create our toolpath. So let's take a look at the upper right hand corner. We can see that the part overall length is 4 inches. Okay, and then we also have a 3-inch dimension to the intersection where the angle starts. So that is one piece of information that we have, and that is on this top leg. And I'm going to go ahead and turn the triangle on. We have this leg right here. We know that that is 1 inch. Okay, so we need to know the distance of this leg, and in order to calculate that we need 2 pieces of information. So we know we have one that is 1 inch, and then the next piece of information we do have is a 110-degree angle. So we know that if we have a sharp corner or right angle corner, it would be 90 degrees. Now this is 110, so 110 minus 90 leaves 20. So this leg, which would be the hypotenuse of this triangle, is at a 20-degree angle of this adjacent leg. If you've watched my video last week, then you'll know why this is called the adjacent. This would be the opposite, and this is the hypotenuse. So we know we have a 1-inch leg and we have a 20-degree angle. So now we have 2 pieces of information to calculate the length of this third leg or opposite leg. And that is the information we're going to need to make our toolpath come from this intersection right here to this intersection right here. So let's see what formula we would actually use to calculate the length of this side. So the formula we're going to use for this particular triangle, in order to find the length of this opposite leg, we're going to take the tangent of our known 20 degrees times the adjacent leg length, which is 1 inch. And the 1 inch was 4 inches minus 3 inches. So this straight section of the adjacent leg is exactly 1 inch. So let's pull up the calculator. We're going to plug in 20 degrees. We select tangent, and then we're going to multiply that times that 1 inch equals 0.3639, 4-place decimal. We're going to round that up by 1/10 and make that 364. So that length is 364. So this intersection will be x4 y minus 364. So that's how trig is used to find the intersection points of angled geometry. So let's go on to the next corner. Alright, so let's take a look at the information we have on this angle here. We have 135 degrees and we have a 707 dimension. So we need to find the triangle to be able to calculate the distance to this intersection point right here. So we know that the overall height of the part is 3 inches. So we need to figure out what the distance is of the leg of the triangle that sits in here. So let me turn that triangle on. And that's the challenge sometimes, is finding these triangles. So this is the triangle that we're going to use to calculate this leg, so we know where this intersection point is based on the 2 pieces of information that we have. So if I turn on a dotted line right here, we know that these 2 legs are 90 degrees. So if from this leg to this leg is 135 minus 90, that means we have 45 degrees between this leg and this leg. Okay? So we know we have 90 degrees between these 2 legs, and if this leg is at 45 degrees, then the remaining of that 90 is also 45. So we know that this corner right here is now 45 degrees. So that's the 2 pieces of information that we need, is the angle, and we have the length of one of the sides. So in this case, we know the length of the hypotenuse. So in a triangle, we know that the three corners of the triangle always have to add up to 180. Okay, so if this one here is 45 degrees, and we know that this is a right angle, which means 90 degrees, that's 135. That leaves another 45 degrees to make the 180. So we know that this corner here and this corner here is 45 degrees. So the formula we're going to use is the opposite leg. So we can call the opposite either this or this leg, and we should end up with the same value. Because on a triangle where we have two corners at 45 degrees, the adjacent and opposite legs are going to be equal. Okay, so the formula we're going to use is opposite equals the cosine, and we use the cosine because we know the length of the hypotenuse. So we take the cosine of 45 degrees and then multiply it times 0.707. So let's bring up the calculator. Let me drag it over here. So we clear this, and then we take 45 degrees, we select cosine, we multiply times 0.707, that equals 0.4999, so rounded up 1/10 again, we know that we have a half an inch. So if that leg is 500 thousandths or a half inch, then the horizontal leg will also be a half an inch. Okay, so the intersection right here will be at x 4 inches, y minus 2.5. Okay, because we know based on the drawing dimension that this leg is sitting at 4 inches. We just calculated this leg at half an inch, means that our x and y coordinate is x4, y minus 2.5. And of course, this intersection now will be x 3.5, y minus 3. So I hope that makes sense. What I'm going to do is I'm going to leave a copy of this drawing as an attachment, and what I'd like you to do is find out what the distance is of the opposite leg right here. Based on the information given, we know that we have 500 thousandths on the length of this leg. We have a 15-degree angle here. So based on those two pieces of information, I want you to calculate the length of this side and then give me the x and y coordinate of this intersection. Good luck.